Hello everyone, welcome to the YouTube channel Mission Net Physics Exam. And guys, in today's video, I am going to discuss some of the very important topics from classical mechanics. So guys, all these topics which we are going to discuss in today's session are gonna be very important topics. Also guys, this is gonna be a video in accomplishment series. So all the topics which I will consider, they are gonna be very important, and every student should know about each and every topic which we will discuss in today's video. Along with this guys, all the topics we will consider quickly so that in very less time you will be able to do the revision of classical mechanics important topics. Okay, so let's quickly start the discussion, but before that I'm just going to tell you about the Unacademy Plus subscription, also its benefits, and about the new courses. I will provide you the information right now. Then quickly we will start the discussion about all those points which we are going to discuss in today's session. And this video will be important for all of you, as well as if you are having some of your friends, those who are preparing for CSIR net physics exam or even for gate physics exam. This video will help all the students, so you can share this video with your friends as well. Also, if you will like this video, you can like it. Okay, now one more thing, that if you are new on this channel, that is Mission Net Physics Exam, then you can subscribe this channel by clicking on subscribe button below this video, and after that you will get a bell icon. You can click on that bell icon to get the notifications for the new videos which I will upload on this channel. In accomplishment series, I am going to provide you all the important subjects, you can say the quick discussion, with the help of which you will be able to do the revision quickly and in very less time. So now let's quickly start the discussion about all the points we are going to consider and discuss in today's session. So guys, as you all know that we are going to have so many courses which are going on Unacademy Plus. But as your exam now, it's like just some time remaining before the exam. Okay, we are having just few days. So in these many days, with all these important courses which are going on Unacademy Plus, like there we are going to have the you can say the quick revision course, as well as we are having the practice course which is going on. Okay, and I'm telling you about the courses in which I am conducting the sessions. Right now I'm telling you those courses. Okay, also guys, if I'm going to talk about the other courses, okay, we are going to have many other courses by all the top educators we are having on Unacademy Plus for your upcoming exam preparation. So guys, in this case, if you are going to take the Unacademy Plus subscription even right now at this time, the courses which are going on, okay, when you will attend the sessions of these courses, they will help you a lot to do the best possible preparation in the remaining time before the exam. Also guys, by using and by applying the referral code, that is Anjali Arora, as it is mentioned here, you will be able to get the 10% discount in the total Unacademy Plus subscription amount. There should be no space in between, spelling should be same. That's how you need to write it and apply it to get the 10% discount in the total Unacademy Plus subscription amount. One more thing guys, right now the sessions which are going on in these courses, along with these courses there is a crash course which is going on. Okay, and in that crash course, even right now the practice sessions are going on. So like the session timings, if I am going to tell you, 9 a.m. okay, the one class we are having, which is the practice session. Then this one we are going to have at 4 p.m. 4 to 6, this is 9 to 11. Then the next one is 7 to 9 p.m. okay. Now this is how we are going to have the sessions. Also, if I am going to talk about rest of the classes, in between even we are having the sessions, but they are the in the the Revised India series. Also the other one, just the frequently asked questions that we are discussing in those sessions, and for that even I will provide you the information. But these are the well structured and the well planned courses. Okay, timing I have mentioned here, and all these courses will help you a lot to do the best possible preparation in the remaining time before the exam. And guys, if you have missed any of the sessions, you will get the recordings of those sessions, and that's how you will be able to cover up each and everything, whatever sessions you have missed. Even you will be able to cover up the discussion which we have done in those sessions with the recordings which will be available to you. Okay, So guys, these are the benefits of taking the Unacademy Plus subscription. As you all know, the Revise India series is going on Unacademy Plus. Okay, I am going to conduct the sessions in this Revise India series from Tuesday to Friday at 1 o'clock. Okay, you all can attend these sessions. Also guys, one more thing, that on Monday I conduct the session, but it is gonna be the championship mock test analysis session. Okay, so you all can attend these Revise India series sessions too, from Tuesday to Friday at 1 o'clock. Also guys, revision courses, as I have already provided you the information about it, you know about it. Okay, now let's talk about the points we are going to cover up in today's video. So guys, if I'm going to talk about classical mechanics, if you are someone who has not prepared it yet or who has already prepared it and completed it, in both the cases, this video is going to be helpful for you. Now let's quickly start the discussion, and each and every point is going to be very important for all the students. The first point I'm going to consider here, that's going to be from the Lagrangian dynamics. Then we will talk about Hamiltonian dynamics. Then we will talk about the tricks in between. Then we will talk about the rest of the important topics. So that means in today's session, many important topics we are going to cover up. Okay. Now let's talk about the first one. And it's going to be a quick discussion. So I hope you will be able to know about each and everything well. I will keep on telling you the important points in between. So let's start it now. Guys, if we are going to talk about the Lagrangian is what? It is basically the difference between the kinetic energy and the potential energy. What we mean by difference? Can we write anything? No. The sequence is going to be fixed, which is like T minus V, which means kinetic energy minus potential energy. Okay? This is the first thing you all need to know from the Lagrangian part. Now, Lagrangian is what? Kinetic energy minus potential energy for any given system. Just find kinetic energy, find potential energy, take their difference, and that's how you can get the Lagrangian. Most of the times, students are going to have this difficulty that we know what is Lagrangian, but how to find the potential energy and how to find the kinetic energy, we face difficulty in that. So guys, for this one, I'm going to suggest you one thing, that for the basic systems, you can start finding the potential energy expressions, the kinetic energy expressions, observe them if you are making any mistake anywhere. And that's how step by step when you will do it, you will have the confidence regarding this, that you can find the kinetic and the potential energies quickly. After this guys, the next point you need to know is Lagrangian is a function of generalized coordinate and generalized velocity. Very important point. Next point, what is gonna be the Lagrange's equation of motion? Okay, that is d by dt del L over del Q dot, where Q is the generalized coordinate but Q dot is the generalized velocity, minus del L over del Q is equal to 0. In which this del L over del Q dot is known as generalized momentum. Only this much part is known as generalized momentum. Okay, next point. If we are going to talk about the role of Lagrange's equation of motion. So guys, if you want to know about the system, you want to get some information regarding the system, then you are going to you can use the equation of motion. You can get its like final solution, and it will help you to get the parameter related to the given system. That's how it will help you. If I'm going to talk about the next point, that is related to the Lagrangian itself, the one point I have mentioned related to generalized momentum, it's very important. If any system is going to have more than one generalized coordinates. Generalized coordinates are basically the coordinates which you need to define or to explain that system and to write its equation. Okay. So basically for each and every generalized coordinate, you will have a separate or individual equation of motion which you can write. Another very important point is equation of motion is also known as Lagrange's equation of motion is also known as Euler-Lagrange's equation. Okay, next point. If I'm going to talk about the next point guys, that is related to this thing, that if you are having the Lagrangian given to you. In that Lagrangian, let's say I'm just going to write the expression right now. L is equal to half m x dot square plus half m y dot square minus 2mgy. Okay, this is like the second term is going to have the y dot. This is x dot. Now the point is, in this case, which is cyclic coordinate. Okay, so to know about it, you need to know one thing. The coordinate whose derivative is present in the Lagrangian and the coordinate itself is not present in the Lagrangian, that is cyclic coordinate. If we are going to talk about this equation, here x dot is present, okay, but yx is not present. Clear? So x is cyclic coordinate. If we are going to talk about the y dot is present, y is also present, y is not cyclic. Okay, so that's how you can know about the cyclic coordinate. Once you get to know about the cyclic coordinate, its corresponding generalized momentum will be conserved. So whatever is cyclic coordinate, if I am saying this x, so px component of generalized linear momentum or generalized momentum, you can say, okay, that will be delta L over delta x dot. It will be conserved, while this one corresponding to y will not be conserved. So this is conserved or constant of motion. If I'm going to talk about the next one, guys, that point is related to Hamiltonian dynamics. Also, one more thing I would like to tell you in Lagrangian part, that is, if Lagrangian does not depend on time explicitly means t is not written there, it is not exactly visible, then you will say the energy of the system is conserved. For example, here you can see this is the Lagrangian expression we have mentioned. Here you can see there is no t present, t is not actually present. So we can say energy of the system is conserved. But if I am going to write t here, now t is present, the energy of the system will not be conserved now. But if it is not here, then energy of the system is conserved. If I am going to talk about the next point, that is related to Hamiltonian. Hamiltonian is equal to t plus v. Hamiltonian is like something, just like when you are writing the Lagrangian, it's t minus v, Hamiltonian is t plus v. Hamiltonian will be the function of generalized coordinate and generalized momentum. It's very important again. If we are going to talk about rest of the points related to Hamiltonian, which are very important, these are the firstly the Hamilton's equation of motion. If I am going to talk about the equation of motion, for them do this thing, write q dot first, write p dot, then write c. Q is something which is telling us about the generalized coordinate, which means position. We are getting to know about the position. In this case, what we will do, position we are getting first, okay, and then we are going to write the momentum term. This is like q dot is equal to delta h upon delta p, where h is the Hamiltonian. Positive sign, because you got to know about the position. Basically, q dot is generalized velocity, but q is the term which we use, or which is going to represent generalized coordinate. So that's how, like, you can say. Done. Now in the second case, you are firstly writing the momentum and then you are writing the generalized coordinate term. Is it okay? No, because firstly we want to know about the position where we are finding the momentum, or where we are considering that momentum particularly. Okay, so when this is the case, when we are writing the position related coordinate first, then you will say it's positive sign here. When you are writing momentum related coordinate first, it's negative sign there. Most of the times students are going to have doubt regarding these equations. I hope now it will be clear to all of you. Let's talk about the next equation, guys. That is the equation which is going to help us to do the conversion, or to convert the Hamiltonian into Lagrangian, or Lagrangian into Hamiltonian expression. So that equation is h is equal to summation q dot p minus L. Okay, this is very important equation or expression. If I am going to talk about the next point, that is related to total time derivative of any given function. Let's say a is a function, so total time derivative of this function will be equal to the Poisson bracket of a with h. H is the Hamiltonian here, plus del a by del t, where this del a by del t is the partial differentiation with respect to t. Okay, we are finding for this given function. Now, if any quantity is conserved quantity or constant of motion, in that case the Poisson bracket of a with h will be equal to 0. This is a very important condition, and you can use it to know whether any given function or quantity is conserved or constant of motion or not. If it is going to satisfy the last condition, that is the Poisson bracket of that quantity or that function with Hamiltonian of the given system, if it is equal to 0, that quantity will be conserved or constant of motion. If I am going to talk about the next point, that is related to the Poisson bracket. When we are talking about the Poisson bracket, some of the students we can have here, those who don't know about it, how it's gonna work, how it will give you the expression and the equation you need to form to solve such type of questions. So let's talk about it, guys. Let's say there are two functions present within the Poisson bracket a and b. Generally you need to focus on the generalized coordinate and generalized momentum, okay, to solve any such type of questions, okay, related to Poisson bracket. So the first term, partial differentiation, you need to do with respect to generalized Coordinate can be x, can be y, can be z, can be x, y, z all present in the expression or the functions a and b. So if it is only x right now we are considering it, what you will do, delta a upon delta x, delta b, second term with respect to momentum, you will do its partial differentiation. Okay, px I can represent to just show that it is the x component of linear momentum, minus interchange the denominator, first term with respect to, just do its partial differentiation with respect to px. Okay, second term do its partial differentiation with respect to x. Clear? Now if I am going to talk about the next point, if there are going to be more than one variables, let's say here we are not having only x but we are also having y, so what we will do, plus delta a upon delta y, delta b upon delta py, okay, minus delta a upon delta py and delta b upon delta y. So that's how the number of variables which are present there, depending on that you can write the Poisson bracket expression, and this is how you can solve it easily. Be careful about the sequence, whatever is present first you need to do its partial differentiation initially with respect to position coordinate, the second one do it with respect to the momentum coordinate, okay, and that's how, like, the interchange the denominator, take a negative sign, like it will remain same. This is just a way to memorize the formula you can consider. Next point guys, if we are going to talk about the next point, that is related to canonical transformation. In general, if you want to check, like let's say this is the transformation which is taking place, this is like the old set of coordinates, now they are getting converted and we are getting new set of coordinates from these ones. So is this transformation which has taken place where q is a function of generalized coordinate, which is the old one, and generalized momentum, as well as p is also a function, another function of generalized coordinate and momentum. But this transformation which has taken place, we want to know whether it is canonical transformation or not. For that, what we need to do, we just need to check whether the Poisson bracket of new set of coordinates with respect to the old ones, is this equal to 1? If it is equal to 1, it is a canonical transformation. If it is not equal to 1, it's not a canonical transformation. If we are going to talk about the source here, which will help you to do the conversion or this transformation, how it will take place, you need something for that. For example, and to consider the points easily, we are saying okay, the generating function is gonna help us to do this conversion. So what are these generating functions? Basically there are 4 different type of generating functions, f1, f2, f3 and f4. So basically how we write all the type of generating functions here, there are total 4 variables or 4 coordinates, q, p, q, p, okay, the old ones and the new ones. You just need to write them like this, q, q, p, p, okay, the old ones first, then the next one, q, q, p, p. Like you are going to write the all the possible cases when you toss a coin twice, or you toss 2 coins together. So you usually write H, H, T, T, H, T, H, T. Okay, H, T, H, T. That's what you do. Same thing we are doing here, but the first term we are writing with the old set of coordinate Q, Q, P, P. Then the second one, new set of coordinates Q, P, Q, P. That's what we have done here. Now out of these 4 coordinates, whatever is not present here, you will write that one and you will write the formula for that one. So P is not here, also capital P is not here. Small and capital, both P's are not present here. In this case, small p and see Q, P, Q, P. I have just mentioned Q, Q, P, P, which is not correct. It should be Q, P, Q, P. Okay, that's how you need to write it. Alternate way. So like you write this same way. Q, Q, P, P, Q, P, Q, P. Done. What is not present here now? Q. Okay, which one is not here? Q. And which one is not here? P. Which one is not here? Q. Which one is not here? Capital Q. Like this. Done. Now what you need to do, write them in sequence like this, Q, P, Q, P. What you will do, the last one and the first one, take the negative sign with them, while the rest of the formula you can just easily write by taking positive sign. So small q negative and capital P negative. That's how you need to consider it. Clear? If I'm going to talk about the function, this is the first kind, generating function of first kind. So delta F1 upon, this is the old set of coordinate which is generalized momentum. Corresponding to this, the other coordinate will be q. So you just need to write it in this way. Del F2 upon del q. Del F1 upon del capital P, its companion is capital Q. Write it like this. Del F2 upon del capital P. del F3 upon del capital small p, because small together, del F3 upon delta capital Q. Okay, next one. If we are going to talk about next one, that's going to be delta F4 upon delta small p. Okay, that's how like you can write them easily, and it's like you will not have to put extra efforts to memorize all these values. I think it's going to be quite easy for you. Now, if we are going to talk about the next one, that is related to the Hamiltonian. Let's say if there is Hamiltonian here, you are going to have h for the old set of coordinates and h dash for the new set of coordinates. How they are related to each other? So the equation or the relation between them is h is equal to h plus delta f upon delta t, where f is the generating function here, h old set of coordinates corresponding Hamiltonian, h dash new set of coordinates corresponding Hamiltonian. Next point, related to Lagrangian, guys, one more point you need to note down, that is action. What is action? Action is basically the time integral of Lagrangian. Anytime if you are getting the question based on it, that is time integral of Lagrangian is known as action. Clear? That is, this is equal to integration t1 to t2 L dt. If we are going to talk about the next point, you need to know related to all these points which we have discussed till now, that's going to be related to action angle variable, which is j. J is equal to integration p dx. P is the generalized, that's just classical momentum, okay, or normally you can call it momentum. X is the position, okay, element or coordinate you can say. Done. This is the formula for the action angle variable. If I'm going to talk about the formula for t, that's gonna be delta j upon delta e. Okay, that is what t, time period. So anytime if you want to find this, you can find it with this one. Okay, now let's talk about the next point, guys. After knowing about all these things which are very important, you should also know about few more points. Like, if I'm going to talk about the stability analysis topic, normally you get the potential energy expression. Okay, it will be given to you in the stability analysis topic. Once you are having this potential energy expression given to you, what you need to do, you need to find the equilibrium points first. Okay, just if it is function of x, equate the delta v upon delta x with 0 and get the values of x from here. Once you are getting the values of x, these are the equilibrium points. Now you need to check with the second order derivative of potential at let's say there are 2 points or 3 points, whatever number of points you are getting. Let's say you got 2 points. So at x1, now you need to check the second order derivative of potential, whether it is greater than 0, or let's say we are taking both the examples here. At x2 point, x is equal to x2, it is less than 0. Greater than 0 means here you are going to have more votes for this term. Greater than 0, it's a stability condition. Stable means it's minimum condition. Minimum means it's like a graph you are going to have in this way. So this is minima. If you are going to keep something here, it will not go anywhere. It's a stability condition or a stable condition. The other one is if you will put something here, it will fall down or it can fall down. So it is less than 0, which is unstable condition and maxima condition. So this is for unstable and maxima. Now, after knowing about maxima and minima, you need to just as per the question, you need to take the next step. If they have asked you to find the time period, that is t is equal to 2 pi by omega, or if they have asked you to find the omega, which is angular frequency. So omega is equal to what? That's gonna be root k by m. What is root k by m here? So what is k exactly? K is equal to d2v upon dx square at that particular value of x, wherever you are going to have, okay, the stable equilibrium point or unstable or whatever they have asked you in the question, that point you need to consider here. Okay, that will be the k value. This is what? This is k value. If we are going to talk about the next point, that is related to, so from this one you will get to know about the angular frequency. If I'm going to talk about the next point, that's related to this thing, that any time if in the question it is mentioned that the question is related to circular orbit, angular momentum, something like this, so instead of this v, you will use the effective potential. The effective potential is gonna be you can write it in this manner, that is j square upon 2mr square. Okay, j is the angular momentum here plus v which is given to you. Then according to this expression, you will just take the further steps and you will get to know about the right answer. So anytime in the question, if they have used the central potential, central let's say circular orbit, basically circular orbit, or angular momentum, mainly these are the hints we are going to get. Okay, circular orbit or angular momentum term is that they have been used in the question. Instead of using the direct potential expression given to you, you have to use this potential, which is effective potential. Okay, next one. If I'm going to talk about the next point, that is related to the frequency of normal modes. For finding the answer for frequency of normal modes, you will solve this determinant, which is v minus omega square t is equal to 0. Now how to write v? Let's say Lagrangian is given to you. Generally Lagrangian will be given in any such system, which is half m q1 dot square plus half m let's say half 3m q2 dot square, then minus, or let's say it's gonna have half 2k, okay, q1 square plus 2 and 2 can get cancelled out, so let me just make it 3. Done. And let's say here you are going to have plus 1 upon 2 5k q2 square. That's it. Okay, let's say this much you are having, but I will take one more term to make the points more clear to you. Let's say the next term is plus half 5, okay, k q1 q2. Done. So in this case, what will happen? You want to write the potential energy matrix corresponding to that. What you need to do, you need to write the q1 coefficient, and half don't consider it, you need to keep it common. Except half and except this q1 q2 term, whatever will be remaining one, that you can write here. But how? I'm telling you now. See, so 3k is here, q1 you will consider this first position, the first row and first column, like that, 3k. The second one, q2 which is second row and second column, that will come here, which is 5k. A half you don't need to write, q2 square, okay, so that is for this particular position. Again, half don't consider it, you need to keep it common. q1 q2, first row second column, second row first column, both you need to consider. The half of this term you will write at both the positions. 5 by 2k, 5 by 2k, like this you will write. Half of this 5k you are writing, this half you need to save, it will be common, it will stay there, okay. But this is the potential energy matrix you are going to form. How you will form the matrix for the kinetic energy? In the same way, but this time you have to take the coefficients of q1 dot square and half q1 dot square, basically half and q2 dot square. So what you are getting from here, m, and what you are getting from q2 dot square, 3m, 0 0. This is the kinetic energy matrix, okay. That's how you are going to get the potential energy and the kinetic energy matrices. Now if we are going to talk about the next step, just put these matrices here, then get the value of omega, and they will be the frequencies of normal modes. That's how you need to proceed. It's quite easy, every one of you will be able to do it in this manner, okay. Next point, next topic we are considering, that's going to be related to the phase space dynamics. To draw the trajectories and to know about the right graph corresponding to phase space trajectories, what are the points you need to keep in mind? I'm just going to tell you these points right now. So basically guys, if we are going to talk about the first one, that's gonna be that if potential energy expression is given, then what you will do, your first step will be to draw the v versus x graph, okay. The second step will be just observe if in the v versus x graph, like you have drawn it like this, v versus x graph, below this you will draw the momentum versus x graph. What you need to do in this graph, let's say this is v is equal to mod x or a mod x. I am just taking a simple example to make it clear to you. Now you have drawn the graph first, okay, or let's say just a x is given where x is greater than 0. So only positive x side you will consider in this case. Now your second step will be to draw the energy lines. Okay, you just need to draw the energy lines. Energy lines are the lines parallel to x-axis. So you will draw them. Now, wherever the energy line is intersecting the graph, the v versus x graph, corresponding to these points, the value of momentum will be 0. Also guys, this is the third point you can consider, but I will write it later on. I'm just telling you that point right now. The next thing you need to observe is whether when you are increasing the values of x here, the value of v is increasing or not. So wherever v is increasing, the momentum in the momentum versus x graph will decrease. wherever v is decreasing, the momentum will increase. Okay, wherever v is constant, the momentum will be constant too. Okay, so it's same. But if we are talking about the energy line intersecting the v versus x graph, intersecting the v versus x graph, then at those points you will have the momentum in the corresponding graph equal to 0. That means if this type of graph you are getting, the momentum at this point is 0. Okay, wherever the energy line was intersecting the graph. Okay, now the graph means the v versus x graph you have plotted. So this was your fourth point. Now fifth point will be that wherever you are going to have the momentum positive, the value of momentum will be positive here above origin. In that region, the direction of arrow will be towards positive x. Direction of arrow will be towards positive x. So by keeping all these points in mind, you will easily be able to draw the trajectory corresponding to any potential expression given to you. Next point. Next point is like sometimes the questions based on trajectories you can get in this way, that if like let's say the system is of this kind of that kind, done. So if system is conservative, always remember no two phase space trajectories will intersect with each other. Even when the system is non-conservative, the trajectories will not intersect, but in case of non-conservative systems, the trajectories will be connected to each other. That point you all need to keep in mind. If I am going to talk about the next point, that is wherever the motion of the particle is bounded motion, corresponding to that the trajectory which you will get, that will be the closed curve. So guys, these were the points we have considered in today's session, and many important points we have included in this session. If somebody is going to focus on these points, they will be able to solve most of the questions from this part, and all the points are very important. You can't miss even a single point. In upcoming videos, you will keep on getting the important discussion, the quick discussion about the important topics from different subjects. So stay connected. If you are new on this channel, you can subscribe this channel. You can click on the bell icon, and to subscribe, you need to click on subscribe written below this video. Then after that, you will get a bell icon. You can click on that to get the notification for the new videos I will provide you on this channel, that is Mission Net Physics Exam. I am trying to provide you most of the important topics based like videos, and in such a way that in less time you will be able to do the quick revision. Okay, so I hope today's video will be helpful for all of you guys. Please let me know about it in the comments too, like how did you find this video, was it helpful? And mainly, since it is a kind of quick discussion or quick revision in the accomplishment series, so if you are someone like who is going to just prepare these topics for the first time, you may find it quick discussion, because it is quick discussion actually. Okay, so by focusing on the points, by knowing these points, it will be very easy for you to solve the related questions. So mainly you need to focus. If required, you can check it out again if something is not clear to you. It will be helpful for you. Also guys, as I have provided you the information about the Unacademy Plus subscription, right now so many important courses are going on there, and with the guidance of all the top educators, you will be able to prepare very well for your upcoming CSIR Net Physics exam guys. Still you are having time, still in this time, like you can do the best possible preparation. Also you can take your preparation to the next level. These are the sessions I have mentioned, like the timings when I am conducting the plus course classes, the 9 a.m, 4 p.m and 7 p.m. These are the timings before your exam. Okay, for the courses which are right now going on. Also the strategy course is soon going to start on Unacademy Plus. Okay, so guys, still you can check it out. Like only I have mentioned the sessions which I am conducting right now. Along with these sessions by other educators, there are many other sessions which are going on. So after taking the Unacademy Plus subscription, you will be able to attend and watch all those important sessions too. Okay, and that's gonna be like something very important and will help you all. Okay, with the guidance of all the top educators, you will be able to prepare very well for your exam. So if you want to attend the live sessions of all these important courses, you want to use this time in this way, okay, to get many important points in very less time, so it will be helpful for you. And by taking the Unacademy Plus subscription, you can attend the classes of all these well structured and well planned courses. Also guys, by using and by applying the referral code, which is Anjali Arora, as it is mentioned here, you will be able to get the 10% discount in the total Unacademy Plus subscription amount. Okay, Thank you so much everyone for joining this session, for watching this video till the end basically. Thank you everyone. Thank you. Also, if you are new on this channel, please subscribe this channel, okay? And by clicking on subscribe written below this video, you can subscribe it. Also, after that you will get a bell icon. You can even click on that to get the notification regarding the videos I will upload on this channel. And if your friends are preparing for the exam, don't forget to share this video with them too, because it will help you as well as your friends to prepare for the exam very well. Thank you everyone for watching this video till the end. Thank you.